Um, this is a general update, although I thought it'd be interesting to do a video when I'm really, really sick. So we'll just see how it goes. It's Sunday, 16th of July. It's 5:30 in the evening, and I'm very sick. I had chemo on Tuesday, Wednesday, Thursday this week, and it's kind of been the worst of the kind of good chemo. So I mean, when I was initially having chemo last year, that was much worse than now because I had the terrible skin rash, and I was having the full mixture of chemos called Folfox, which includes a platinum-based poison called oxaliplatin, which is just horrific, causes lots of nerve damage, and was really nasty. And since then, when I've sort of had the less chemotherapy, so now I just have one chemotherapy agent really called 5-FU, and also a molecular targeted agent called Avastin. It's been okay, really, but it's getting really bad now. Mainly fatigue, so I've just been exhausted over the past few days. Every time I have chemo, before I have chemo, I have to have a blood test to see if I'm healthy enough to have it, and I was healthy enough to have the chemo this week, but the oncologist did say that my blood test showed I'm anemic, and also that the platelet count is low. So obviously anaemia, iron deficiency means that your blood can hold less oxygen. The hemoglobin in your blood is kind of less able to get hold that oxygen, which makes you very, very weak. And the low platelet count, I've actually noticed recently little cuts and scratches will sort of bleed a lot longer than they should, and the blood is like noticeably more watery because it's the platelets that help you, let your blood clot and make it so sticky. So yeah, very tough at the moment. So as I said in a previous video, I had intensive immunotherapy recently, but didn't seem to have worked, although I have to say the recent CT scans showed the tumour's still shrinking, and the oncologist obviously thinks this is due to chemotherapy. The immunotherapist sort of saying, well, wouldn't really expect to get tumour shrinkage just from chemo at this point. So although the intensive immunotherapy didn't have the sort of dramatic effect of getting rid of some of the tumours, I do think it's shrunk them, and it's kept my physical condition pretty good, at least in between chemotherapy. I'm not really sure why the intensive immunotherapy didn't work. Basically what happens is, for some reason, in some cases, the immunocells, the sort of white blood cells and things that are put in your body in the immunotherapy, instead of moving around your immune system and attacking the cancer tumours, they get absorbed into the tissue of the body, into the muscle and fat and that kind of thing, very quickly, and sort of also kind of go straight into the lymph nodes where they get released into the blood and broken down. So the point of intensive immunotherapy, at least this kind of immunotherapy, is to saturate the body with white blood cells, and the immunotherapist has sometimes got quite dramatic results from this. But talking to the immunotherapist, he does think it's worth trying again, probably in September. So I'm going to do some big fundraising efforts that will basically one thing is I think I need to get some media coverage because so far all the donations have come from friends and friends of friends and friends of their friends. Some from strangers, but mainly people who have some kind of connection to me, which is amazing. But I think obviously people are giving again and again. So everyone's running out of money, really. So I'm going to approach newspapers, online media, that kind of thing, and try and get some media coverage. There's been no, as far as I can tell, and I have looked into this a lot, there's been no long-term survivor of bowel cancer that spread to the peritoneum. So I'm fighting hard to be the first, and I think immunotherapy is the way to do that. I listen to some cancer podcasts by doctors. And so oncologists and immunotherapists and that kind of thing. And I heard an oncologist, an American oncologist, explain what she felt was the key difference between immunotherapy and chemotherapy. And I think she put it very eloquently. She said, two things. So first of all, she said, chemotherapy is essentially poison. And the idea is that you try and kill the cancer without killing the host, or i.e. the person who has the cancer. Whereas immunotherapy, the actual agents, they're far, in the way that you handle them, they're far closer to she actually said nutritional supplement or whatever. You can spill it on your clothes, you could drink some. It's horrifically expensive, so you wouldn't want to do that. But chemotherapy. The first hospital I had chemotherapy. The chemo nurses had the plastic face guards on, gowns, elbow length gloves. Everything is put into like a biohazard bag. It's serious stuff. Dangerous poisons. That kill people, whereas immunotherapy, my immunotherapy consists of my white blood cells that have been cloned in a lab, really, and then put back in me, perfectly safe. I mean, the nurses do wear gloves and stuff, but it's completely safe. And then this oncologist, she said, think about how it works. Immunotherapy has these two massive advantages really over any cancer treatment. And one is specificity. So immunotherapy is able to target cancer tumours, whereas other treatments just aren't able to do that. It seems to be possible to get chemotherapy to target tumours in a limited sense with some chemotherapies, but not using the chemotherapy by itself. You have to have other agents or hypothermia treatment or a chemotherapy agent that is triggering an immune response. And then she said that the other huge benefit of immunotherapy over any other cancer treatment is immunotherapy has a memory. So when you're using immunotherapies, you're actually teaching the immune system to attack the cancer, either by teaching it to target the cancer or to stop the immune suppression response. So cancer has many techniques for many powerful techniques for stopping your immune system working, hiding. Sometimes it's about hiding from the immune system. Cancer tumours are protected from white blood cells by a layer of acid, lactic acid, that's in what's called the tumour microenvironment. But when you have immunotherapy, every time you have it, it teaches your immune system a bit. So the immunotherapy I have, one form is called NK cell immunotherapy. So NK cells are these natural killer cells that kill cancer tumours, and one NK cell can kill up to about 30 cancer cells, and the immunotherapists will sort of flood your body with like billions of these cells, and the white blood cells basically get used up and get sort of destroyed naturally over about 24-hour period, but the memory lasts for about 3 months. So up to about 3 months afterwards, your immune system is still elevated in terms of NK cell activity and NK cell proliferation, like how many you actually have. So even though those cells are sort of dying up within 24 hours, it's sort of teaching your immune system. Another type of immunotherapy I have is it's dendritic. It's called dendritic cell cancer vaccine, which again teaches the immune system to attack the cancers instead of ignoring them. So immunotherapy is such a powerful tool, and bizarrely, it is honestly it is ignored. It's kind of hard to explain this, but in the tech world, we know how to make progress. Really, we know that to make rapid progress, you aim for simplicity and things that scale. We know that if you can eliminate things, whether it's steps in a process or a resource that you're using, that has an effect much bigger than trying to make incremental improvements in efficiency. And this sort of thing just isn't known in the medical world. So if you talk to any oncologist about cancer, they'll talk about the 3 pillars of cancer treatment: surgery, chemotherapy, and radiation. They won't mention immunotherapy. They definitely, maybe a couple, but they definitely won't mention hypothermia. And very few will mention these super high technology, minimally invasive treatments like laser ablation, where sort of a 1 millimeter probe is inserted into the tumour and a laser is used to heat and destroy the tissue, or CyberKnife, where 96 low radiation beams are focused so that the radiation is only enough to destroy tissue at the point where all 96 meet. These, an oncologist might kind of include that as a part of radiation treatment, but it's not. It's very, very different, because the patient leaves hospital the same day with no side effects. So, up till now, the trend in medicine is always to have a variety of treatments, because many won't work in many cases, and also because patients may not be able to handle the side effects. And what we have to do to really get to the next level of medicine is start getting rid of as many treatments as possible and have just a handful of universal treatments. So my immunotherapist, his brother, is also a research scientist and a medical research scientist, a pioneer of medicine, and has been developing this sort of treatment, universal wound healing treatment, based on stem cells. It doesn't actually contain stem cells, but they take stem cells from adult donors from dental pulp. Hopefully not Chinese prisoners or whatever. I didn't ask too much about that. What it means by an adult donor. But they take these dental stem cells from dental pulp, and they put in a gene to an immortality gene, so the cells never die, and then clone the cells, but also they use the cells to make these what they call bioactive molecules. I think over 100 types of bioactive molecules, and then these go into the medicine. And then you spray this on the wound and you get accelerated wound healing. Whereas usually you'd go to a dermatologist and they'd have a whole bunch of things, and they might try a wet method of wound healing or a dry method of wound healing if they're concerned about infection. And you might find when I was having treatment for necrosis in my foot, I was given this sugar paste full of iodine, and it was very, very painful. And the idea was sort of to dry out and firm up the skin. And then I stopped having that, and in fact that was actually the second medicine. I'd previously had a steroid gel or steroid ointment, and steroids suppress the immune system, so you're more likely to get infection. And I'm now using another medicine called prostadine, which is a Japan-only medicine that is meant to heal wounds by increasing blood flow to the wound and also helping the platelets gather there. But really, we just need something that you just should be able to spray on this stem cell stuff. I did use it for a while, but it was horrifically expensive. Really, really expensive. But you know, unlike immunotherapy, it could be made at scale. But it's so important that you know we sort of get these medicines with no side effects, and move into an era of regenerative medicine where you know all the medicines are kind of much closer to the sort of biological molecules, and are often going to be made, you know, using cells from the patient, so that you know don't get rejected. And yeah, I mean, immunotherapy, it's obviously working well enough for many cancers. Skin cancer being, you know, the kind of go-to example, but also non-small cell lung cancer and this kind of thing. We really need to be using immunotherapy as much as possible, because in the tech world we know that when you do that, the price will come down naturally. We'll get much better at it, and it will simplify things so much because you won't be dealing with side effects. The sort of aggressive immunotherapies like checkpoint inhibitors, they definitely can have side effects, but they're pretty manageable. Even the toughest ones, and also they're not accumulative. They don't destroy your body, so you might get an overreaction from your immune system. You could even get sort of dangerous side effects of liver and kidney failure or whatever. But for the vast majority of patients, they can have these treatments quite a lot without getting an accumulative side effect. So yeah, we really have to sort of fix medicine, because there's such a lag between how the technology world deals with stuff and how the medical world deals with stuff. Medicines are being developed in the same way that they have been for sort of 50 or 60 years, and it's ridiculous. The world's moved on so much in terms of technology, but also the things that the tech world knows. In the tech world, we have a knowledge about documentation that, it's just embarrassing when you look at medical documentation and scientific it's a scientific, in medicine, and I guess in science in general, the basic unit of knowledge is the scientific paper. And that may have been okay in the early 1900s, but it's utter nonsense that scientists publish papers in journals and all this nonsense. In the tech world, we document from the beginning, stick the documentation out there as widely as possible. The documentation is completely dynamic. It's not a finished paper. It's commented on. It's annotated. It's a thing that becomes alive. It's got it's essentially, it has emergent properties. It's becomes such a powerful thing. And yet you've got these sort of doctors trying and medical researchers trying to find the time to release papers, and the paper's completely static, and it's sort of released and that's it. Thanks for listening as always. If you can, please share this video and share my fundraising link, which is matthewdons.org. That's matthewdons.org. I'm desperately trying to raise some money to try intensive immunotherapy again, and hoping that this time it will have a dramatic effect and get rid of enough of the tumours that I can then have the others removed by a minimally invasive method. So that's matthewdons.org. Thanks a lot.